Hello dear students, today we're going to do Proposition 20 of Book 1. In any triangle, any two sides taken together are greater than the remaining side. Here's our triangle. In any triangle, any two sides taken together are going to be greater than the remaining side. This and this are going to be greater than this, and this are going to be greater than this, and this are going to be greater than this. Any two sides taken together are going to be greater than the third side. Let's just pick for now that the blue and red side, we're gonna prove that those two sides are greater than the black side. Okay, look how big that black line is, but we're gonna prove that these two are greater. Okay, and to do this, we're gonna use our bag of knowledge. I'll tell you in advance. We're gonna use the reality of isosceles triangles, that the angles at the base are equal. We're gonna use what we learned in Proposition 19, that in any triangle with one angle greater than the other, that the side opposite the greater angle is greater than the side opposite the lesser. Do you remember that? And then I think it's Proposition 3, we're going to cut from the greater line a line equal to the lesser. We know we can do that. Let's start off now by extending this blue line. Okay? Let's cut from the, so we just extended it indefinitely. We're going to cut from the greater a line equal to the lesser. If it's not greater, we'll make it greater. Keep going. And we cut from the greater a line equal to the lesser. Let's do that. Okay, and we're just going to dash it up here a bit so you can see the difference. I'm going to show that for you later. Okay, so this line here is equal to this line. We made it so. Let's connect these 2 points. Great. Now we've got, let's just consider this triangle with the blue side, the green side, and the black side, okay? And then within that, we can consider right now this triangle, the dashed blue side, the red side, and the green triangle. Let's just consider that right now. What do we know about this, triangle? That this side is equal to this side. We made it so. We cut this side equal to this side. We can use that now to say, here we have an isosceles triangle. And what do we know about isosceles triangles? That the angles at the base are equal. That this side, this angle, is necessarily equal to this angle because it's an isosceles triangle. The angles at the base of an isosceles triangle are equal. Great. But look at this angle. It's part of a greater angle. Okay, that's cool. Part of a greater angle. And we know that the whole is greater than the part. That's great. Well, if this is greater than this angle, and this angle is equal to this angle, we know that this angle is also greater than this angle. Let's do this one more time. If this is equal to this, and this is greater than this is also greater than this. Okay. Let's now look at this big old triangle. Where this is an angle, this is an angle. And this big old triangle, this angle is greater than this angle. What do we know about triangles that have one angle greater than the other? That the side opposite the greater angle is greater than the side opposite the lesser. Okay. Great. So this is greater than this. Okay, great. But this is made up of this and this. This line is made up of this line and this line. Okay? Well, if this whole line is greater than this, obviously the parts taken together are greater. Okay? So this line plus this line are greater than this line. Great? But this line and this line are equal to this line and this line. Why? Because this line is equal to this line. So if this equals this and this are equal to this and this as well, because these two lines are equal. But this and this were proven to be greater than this line. This line and this line taken together were proven to be greater than this line. Okay, well this line and this line are equal to this line and this line. Yeah, well if this line and this line are equal to this line and this line and this line and this line are greater than this line and this line are also greater than this line. But this line and this line were the two lines we wanted to prove in our original triangle to be greater than the third side. And that's what we just did. In any triangle, two sides taken together are always greater than the remaining third side. So let's do that one more time. In any triangle, two sides taken together are always greater than the third side. Quod erat demonstrandum. Thank you. Bye-bye.